All right. Hello, everyone. Welcome back to the second class of the class. So last class we talked about the key concept of public key infrastructure. So just to recap, to understand the public key infrastructure, you have to know what the public key cryptography is, right? So public key cryptography is asymmetric cryptography. So we use public-private key pairs, and one nice functionality of the public key pair is if you encrypt something using your private key, it can be decrypted using the public key, vice versa. So using these two concepts, we can, public key cryptography provides two nice functions. The first one is authentication, which is basically a signatures. It is in offline word you sign for when you to write a contract, right? So the underlying assumption of the signature, your signature, is that only you can generate a signature. Okay, but in cryptography, the concept is similar, but how we make this signature is slightly different. So in very high level, signature is just a generating, just a encrypting something using private key. Okay, but the hurdle is if you try to encrypt the entire document, it would be really, really, really big, right? And also the decrypting entire document would take enormous time, right? So compared to just checking the signature and later. So to do that, we apply the hash function first to reduce the original content, and after that we can apply a encryption using private key, so that the receiver can verify the signature using a public key. Okay, and encryption is using a public key to encrypt something, right? But the problem is how you can verify the public key. So we use public key infrastructure, typically hierarchical public key infrastructure, to provide the key integrity and the key identification. Yeah. So last class we learned how DNS works and the limitation of DNS works. DNS. Yeah. So DNS is a plain text message. So the challenge here is anyone can, in the middle of the path, can snatch the DNS response and modify the DNS response to make the users to connect to different machine. So to solve that challenge, we use a DNSSEC. Okay, so the DNSSEC concept is very simple. So we using a hierarchical structure. The verifier DNS resolver needs to fetch only one DNS key, which is root trust anchor, all right? Root DNS key, so that the root DNS key can verify the signature of TLD, top level domain names, private, public key, which can be also used to verify the child Jones DNS key, which can be also used to verify the signature of DNS records. Okay, so you can. So in the last class, I showed you using a dig command to how you can look up a domain names and how you can retrieve the signature, DNS signature, and how you can validate the signature using by simply comparing the key tag. Of course, you have to use a cryptographic library to mathematically prove the signature is authentic, but we can, by just comparing the key tag, we can assume that if the key is matched, then probably the signature should be correct. Okay. So let's move on to the next concept. Okay. So now, so far, we learned DNSSEC is really good. Okay. So if we are using DNSSEC, then we can pretty be confident that DNS response has not been modified at all, right? But the thing is, when you look at the entire domain name, the universe of domain names that you can think of, right? the DNSSEC deployment rate is still less than 2%, which is really, really small. Then you might be wondering, hey, DNSSEC was introduced about nearly 30 years ago, and I can understand that DNSSEC is really good. Then what is the reason why DNSSEC has not been deployed aggressively, right? So let's talk about it more, okay? So to deploy DNSSEC on the administrator's perspective, let's say you manage example.com and you want to deploy DNSSEC, right? So to understand the underlying reason why DNSSEC has not been deployed that much, then you have to understand how to deploy DNSSEC on your server. So first, you have to generate a DNS key. So you can use a command such as OpenSSL, to SSH keygen, all right, or simply OpenSSL to generate a key pairs, and after that, you can use the key pairs to generate a signatures, all right, and after that, you have to generate a DS records again. For the first two steps, so far, you now use your signatures to verify that the DNS records has not been modified, right? But the thing is, still at this stage, there is no guarantee that DNS key, the public key, is actually from a zone, right? Authoritative servers, DNS servers, right? Such as example.com, okay? So to prove that authenticity, to provide that authenticity, we learned that we have to generate a DS record, which is a hash of DNS keys, and we have to upload it to the parent zone, okay? So let's say, if you run a example.com's name server, then you have to upload your DS record to .com zone, .com's name server, okay? So let's first do it. So I just mentioned that the less than 2% of domain names have deployed DNSSEC, but how can we measure that, right? So to do that, we can just run a daily scan. The scan means let's say we have obtained an entire universe of second level domain names. So let's say google.com, example.com, Virginia Tech.edu, let's say we have obtained the entire domain name, right, universe. Then what we can do is we can go to their server and ask for DNS key related, DNSSEC related records, right? If they have a signature, if they have a DNS key records, it means that they try to deploy DNSSEC. If a domain name does not have any DNS key or signatures, you can learn that, oh, this domain name should not support DNSSEC, right? So let's apply this concept, this measurement methodology to all domain names, right? So what you can do is we can go to .com, .org, .net name servers, and we can actually download all the list of second level domain names. Again, .com is top level domain name, right? And under that is second level domain names, right? .com server manages all the list of second level domain names such as google.com or facebook.com, yada, 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 right? So what you can do is we can download the entire list of domain names under this 3 TLDs. Of course, it would be better if we could download all the zone files from all TLDs, but let's focus on these 3 most popular domain names, right? TLDs. So after fetching a list of domain names, second level domain name list, what you can do is we go to each of the servers of the second level domain names and fetch all the DNS records. Okay, so which is over 750 billion DNS records. So now, so of course, it is a side story. So to analyze the 750 billion DNS records, you cannot, of course, run this analysis on your laptop, right? We have to use some distributed systems such as Hadoop, Spark, right? So we use this Spark system to analyze 750 billion DNS records. Okay. So let's first focus on DNS key deployment. Okay? The DNS key, the y-axis shows the percentage of domains with DNS key records, which means we don't know for sure if by only looking at the DNS key record, having a DNS key record does not necessarily mean they deploy DNSSEC correctly, right? It could be the wrong signature, or it could be a missing DNS record. But at this moment, let's just focus on the existence of DNS key record, right? So this is the percentage, right? So at the end of 2016, right, we found that about 1%, nearly 1% of domain names have DNS key records, right? So which means DNSSEC deployment is really, really, really rare, right? But of course, the bright side is growing. But from then how about now? Because this research was done about 5 years ago, 6 years ago. So then it could be, different, right? But still less than 2%. Huh? Then how about the signatures, right? Now the y-axis shows the percentage of the signatures, and the as you can tell, the percentage of domains without, right, no signature is less than 0.23%, which means if you have DNS key, and it is very highly likely that you also produce your signature, because if you run your own DNS authoritative servers, because this step is typically done by the software by running a simple command, the signature is automatically generated as soon as you generate a DNS key, which is good, right? So there is a sharp drop near December. This is because one large hosting providers that manages a bunch of billions of domain names, for some reason they forgot to generate a signature, but after that they started to do so. So which make this which causes the significant drop. Well, so signatures are missing, rarely missing. Okay. Then how about the last step? Okay? The last step is especially very important. Again, you have to, from the DNS resolver's perspective, you have to verify the public key you just fetched from the DNS server is authentic, right? And again, we use hierarchical DNS system structure to support that kind of authentication. Yeah. So y-axis shows the percent of domains missing DS record, all right? Surprisingly, we can find that nearly 30% of domains that have DNS keys and signature, for some reason, they do not upload DS record, right? So in other words, 30% of domain names that try to DNSSEC, try to deploy DNSSEC are misconfigured, right? There must be some reason. Let's take a look. So to understand that, you have to understand the process to deploy a DNSSEC on your server in real world. Okay? So let's say you need a domain name, then you typically go to a registrar. Okay? Registrar is an authorized entity to sell a domain name to the public, such as GoDaddy. Yeah? In Korea, maybe you can go to Kapei-shisa, right? So to purchase a domain name, right? So you go to domain name, so you have you can control your domain name, but the next step is you have to run your own authoritative DNS server, okay? So, and the registrar is the authorized entity to purchase a domain to connect to the database managed by registry. Registry is basically top-level domain name, okay? So for example, .com domain name is managed by VeriSign. So once you purchase your domain name from GoDaddy, GoDaddy will immediately register your domain name into the database managed by the registry. Okay, so that the registry can in the database they can manage your register your domain name, right? And after that, there are typically two choices to run your own DNS authoritative servers, right? The first one is the registrar. Most registrars, they support the by default registrar's default name servers. Okay, so that they manage all DNS records on behalf of you. So that in the case, they may register, the deploy DNSSEC by generating a DNS key, signature, and also register a DS record, right? Publish a DS record and register it to the database, right? Please recall that generate a DS record, and after that, you have to upload it to your parent zone, right? So if your domain name is second level domain name, example.com, it means you have to upload this DS record to .com domain name. So in that case, GoDaddy has ability, right, to access to the database managed by registry database, so that you can simply upload a DS record to the registry. If you decided to run your own DNS server, then you can purchase a VM virtual machine and install DNS software, and after that you generate a DS record and you have to pass it to your registrar, because you do not have ability to access registry's database, right? So which means registrar is the only entity that can access to the registry database. So you have to pass this hashed DNS key, which is DS record, to the registrar so that they can pass it to the registry's database. Huh? If you decided to run outsource a DNS server to third-party DNS operators such as Cloudflare or Akamai, so like CDN services, let's say your domain name really gets lots of attention, became really popular, so you cannot handle all the DNS traffic by yourself, then one choice you can easily make is to use third-party popular at global present DNS servers, right? So in the case, they will manage DNSSEC on behalf of you, generate a DNS key, generate a signature, generate a DS record, but it faces the same challenge, right? Because this third-party DNS operator does not have ability to access the database, registry's database, right? So it also has no ability to access the registrar database. So what you need to do is copy this DS record and pass it to the registrar and pass it to the registry. Now you get some sense, right? Why it is so hard to deploy DNSSEC. Okay? Let me move just one step further. Let's say you bought a domain name from a reseller. Reseller is also sells a domain name to the public, but it is not technically authorized by the registry. So what it does is it has a partnership with the registrar. So that's the reason why it is called reseller. Okay. So if you're using third-party DNS operators, then what you need to do is you pass this DS record to the reseller, so that expecting that this reseller will pass this DS record to the registrar, which will pass it to the registry. As you can tell, it is so complex, right? So now you have some sense why it is so hard to deploy DNSSEC if you are DNS operator. So to understand why DNSSEC deployment rate is so small, we can check how many popular registers out there support this kind of functionality. Okay? So what you can do is we purchase a domain name from a popular DNS registrars, and we check if they support DNSSEC on their name server. After that, we check if they are uploading the DS record to the registry, and if they do so, we run our own authoritative servers and check if the registrars are willing to accept our DS record and upload it to the registry. Okay, so in this case, we became a DNS operator, if registrar is in charge of DNS server, it means DNS operator is the registrar, all right? So there are two cases, right? So we can survey a top 20-ish most popular DNS registrar. So we can check their policy by just manually checking their policy by purchasing a domain from them, right? So based on the research conducted in 2016, only 3 operators support DNSSEC on their name server, which is not good, right? So let me pass it. And also, oh, sorry. And also, if we decide to run our own name server, right, which is owner DNS operator, surprisingly, we found that 11 out of 20 support this DS record, are willing to accept the DS record and pass it to their registry, which is really great, right? But this is really weird, because when you look at the registrar's DNS servers, right, then only 3 out of 20 support DNSSEC on their name server. But one hypothesis would be they might not understand how DNSSEC works, right? But when we look at the owner DNS operator case, they seem to be really willing to support DNSSEC, because, right, they 11 out of 20 are willing to accept the DS record from our users and to pass it to the registry, which means they know how DNSSEC works, right? Then why is this kind of discrepancies coming from, right? We're gonna take a look at it later, okay? And we, let's say, again, DS record is just a long string. So if there are some possibilities that the users might happen to do some copy and paste error, so copy the wrong DS record to the registrar, and so registrar, if they do not check the authenticity of if they do not check the whether the DS record has matched with the actual DNS key without checking it, if they just pass it to the registry, then it means DNSSEC supporting resolver will fail to validate your DNS records, right? Which means your entire zone will become instantly invalid, right? So registrar, as a kind of due diligence, right, they have to check whether the uploaded DS record is actually matched with the DNS owner's DNS key, okay? But only 2 out of 11, they check the DS record, which is so sad, yeah? So, in a quick summary, 3 out of 20 registrars support DNSSEC on their name server. So if you do not want to run your own name server, most of the time, right, the people, when they just they actually don't need to run their own name servers. Typically, they just buy domain names and let the registrars operate their zones on behalf of you, right? But in this case, you cannot deploy DNSSEC and in a chance of 17 out of 20, right? But if you want to run your own name servers, then the chance is slightly better, right? If you want to run your own name server still, 9 out of 20, cannot deploy DNSSEC. And only 2 out of 11 who supported, third-party DNS operator, only check the validate the DS record's validity, which means if you happen to upload an incorrect DS record to 9 registrars that support the third-party DNS operator, your domain name will be inaccessible, right? Because the DS record will be eventually not matched with your DNS key, which makes all the DNS reserved, right, invalidated. So then obviously the question would be, hey, why are DNS support of registrars are so rare, right? The answer is really clear, because think about DNSSEC. DNSSEC introduce much more records, signature, RC, DS record, DNS key records, right? And also, this size are typically larger than 3 or 6 times larger than non-DNSSEC records. And DNSSEC DNS key, right? DNS key is a public key, which means you have to have managed a matched private key. Okay, so this DNS keys is this DNS key is like your password. So you have to use a strong key. You have to use a unique key, and you have to update your DNS key on a regular basis, which is called rollover. So which is very similar to your password policy, right? Which means management overhead is much greater than just plain DNS. Okay? So let's look at the results again. Okay? When the registrar is DNS operator, only 3 out of 20 support DNSSEC on their name server, but surprisingly, 11 out of 20 are willing to accept the DS record handed by you, right? Because at the former case, registrars, they need to manage all DNSSEC related records, right? And the operational cost is much higher than just simply managing a DNS, only DNS, plain DNS records. But in this case, you manage all DNSSEC records by yourself. What registrars need to do is just to accept the DS record and pass it to the registrars. That's it, right? So operational cost for the registrar's perspective is far less, right, than managing name server by themselves. No? So that's why. Then how can you facilitate, how can you improve this current status of DNSSEC, right? So I quickly mentioned that this COM network DNSSEC deployment rate is really, really small. But surprisingly, when we take a look at these two domain names, .nl, Netherlands, Dutch registry, and Swedish domain name, .se, their DNSSEC deployment rate is really, really high. This day it is, in 2020, it is really bigger than, much higher than 50%. I believe they're about 60, 70%, right? So the thing is, the answer is financial incentive, okay? So KPN is a Dutch registry, right? So Dutch registrar. So through this registrar, you can buy .com, .net, or .se/nl domain names, right? But the thing is, Dutch government gives a Dutch registry, offers a financial incentive when the domain name under NL, because it is a Dutch registrar, NL domain name is registered with DNSSEC enabled, right? Because it is a kind of nationwide level initiative to facilitate, right, to encourage DNSSEC deployment, right? Which means they reduce the domain registration fee. Lupia.se, Swedish registry, also similarly, they have the financial incentive to the registrar if they enable DNSSEC for SE domain. Huh? Then let's look at how this financial incentive made a differences in terms of DNSSEC deployment rate. So now, y-axis shows the percentage of domain names with the DNS key and the DS record for 5 different domain names. So in case of NL, right, for KPN, Dutch registry, the DNSSEC deployment rate is really high. It's nearly 80%, right? And similarly, Lupia.se, nearly 100%, which means these two registrars know how to manage a domain name with DNSSEC, right, clearly. Then how about the other 4 domain names, right, SLDs, second level domain names, DNSSEC deployment rate? Can you guess? 0. Because they cannot get any financial incentive, right? By just deploying DNSSEC for these domain names, they cannot get any financial incentive. and they just, got more operational cost. So it is very obvious reason. So financial gain is a huge incentive for DNSSEC, but in the other hand, you cannot offer each registry, they have no clear incentive to provide that incentive to register, right? Which means this solution cannot be, cannot be a kind of ultimate solution. Then let's look at the DNSSEC resolver. Again, so DNSSEC resolvers, so we so far, we only focus on the server side, right? So they need to publish DNS keys, signatures, DS record, but the client side, DNS resolver, they have to use DNSSEC to validate the records, right? So which means DNS resolver has to be ready to support DNSSEC. So to do that, whenever DNS resolver sends a DNS request to the DNS authoritative servers, they have to mention in the DNS request that, hey, I'm supporting DNSSEC. So if you have a signature, please return it back to me so that I'll be willing to verify, right? So that is marked with the DO bit in the DNS request header, DNSSEC OK bit. So if the authoritative server receives the DNS request with this DO bit enabled, they should return with the signature, okay? And of course, the next step is to validate the DNSSEC records, okay? So now we are focusing on DNS resolvers, validators perspective. So, but the thing is, there are more than millions of DNS resolvers out there. And also, the challenge is, it is really, really hard to measure, audit the DNS resolver's behavior because let's say you are in your ISP, internet service provider, in your house, let's say you're using SKT, right? Then you probably, in your home, you use a SKT's default DNS resolver, right? So which means all your DNS requests will be served by SK Telecom's DNS resolver. Let's say I am interested I'm in United States. I would like to measure if your DNS resolver, SKT's resolvers, performs DNS validation, right? To do so, all I need to do is send a DNS request to the SKT's resolver so that SKT's resolvers, take a look if they validate the DNS response or not. But here comes the challenge, because from the SKT's perspective, they do not have any reasons to provide the DNS resolver services to non-customers, right? Because of this reason, SKT's resolvers only accept the DNS requests coming from their customers because they know SKT. They know all the IP address range of their customers. They can easily filter out, right, all the other customers, right, requests, or they can only because they can handle this request in the internal AS so that they can automatically filter out all the external request. So anyway, the point here is that it is really hard to measure ISP's default DNS resolver, right? So there are some previous approaches like using Google Advertisement Network, right? So let me briefly tell you how this advertisement network works, right? So let's say you use Google Advertisement Services, then when you go to the web page, when you see the advertisement, it means you just requested a content to the URL specified in the advertisement, right? Which means you send a DNS request, an HTTP request to see that advertisement, okay? So what researchers have done so far was they registered, for example, 5 domain names in the ad network. So let's say 5 domain names fully signed, but let's say 4 domain names are incorrectly signed, right? So if one client sees this 5 advertisements, 5 different URL, 5 different domain names, right? And if they know these 5 domain names have successfully looked up by the client, it means their DNS resolver may not support DNSSEC correctly, right? Because if they did so, the client was should be only able to see the valid, domain names URL, because the other 4 incorrectly configured DNSSEC records must be invalidated. So the client cannot send a request to that IP address, right? But the challenge here is, if we want to measure the same users or same resolvers, then we have to wait until the user see the advertisement, right? Which means we don't have any control over the node. Okay. So it is not reproducible, right? So one approach we can use is a kind of VPN services like Hola Unblocker, right? So just for your for a brief introduction, VPN is to let you turn on your traffic through another endpoint. Okay, so let's say you travel to another country, but if you'd like to see a Korean Netflix, what you can do is you make a VPN tunnel to a node in South Korea so that you can watch the content, right? Netflix content through the nodes in South Korea, right? The node X node in South Korea will forward all the responses, right, videos through the VPN channel to you in another country, right? So, but the content provider's perspective, they only see the request coming from the South Korea, right? So that's why we are using VPN. So the Hola Unblocker is a free VPN services. As you can tell, as I said, it's free, right? But the thing is, when you install these VPN services, it also installs some software internally in your computer. What this software does is, it lets some other people to tunnel their traffic through yourself, because you just installed a certain software, right? So using this Luminati platform, what it can do is we pick one node in certain country, and we can make it send a HTTP request to a DNS authoritative server, right? DNS web servers under our control. So what it can do is we can run a bunch of many different DNS servers under the different scenarios incorrectly configured and test the same node over and over again, right? So, which means even if let's say we find a node in SKT Telecom, we can use that SKT Telecom nodes to test SKT's DNS resolver, right? So the nice thing about this Luminati is there are many more than billions of users that install the Hola plugin, so that we can measure almost more than 30,000 ASs across the globe, right? So using, as you can tell, we can control over the node. It is reproducible, and then it also scales easily. Okay, so yeah. So what it can do is we make we test whether the local DNS resolver has a DOB enabled, which means they're willing to support DNSSEC. Okay, and after that we test a bunch of different domain names, and many of them are incorrectly configured. So if a DNS resolver can successfully validate all the DNSSEC records, then the client should be only able to send one HTTP request, right? And if local DNS resolver is incorrectly configured, which means they do not care about the validity of the DNS records, then in our HTTP server, we'll see a mass, 8, 9 HTTP requests coming in, right? Because a local DNS resolver did not validate the DNSSEC records, which means they just return the IP address to the end host, okay? So using this methodology, we find that nearly 4,000 resolvers enable DO bit, right? We found about 4,000 resolvers, and 83% of them are DO bit enabled, which means they seem to support DNSSEC, which is good. But in reality, even if they enable DO bit in the header, which means they are willing to accept all the signature, which is much bigger than typical DNS response, but they just throw it, right? They didn't even attempt to validate it. 82% of this 83% of the resolver who are enabled DO bit, they didn't attempt to validate the DNS records, which means incorrectly configured. So only 12% correctly validate the DNS record. Yeah. Then you might be wondering, hey, what about the other 4%? They sometimes validate, sometimes they don't, kind of intermittent, behavior. So we are not that very sure. Okay. So we can test open resolvers, publicly available resolvers, and many resolvers like VeriSign Google correctly checks the DNSSEC records. But sometimes there are some, DNS resolvers, even though they seem to support DNSSEC by enabling DO bit, but still they do not validate it. Also, some resolvers do not support DNSSEC at all, right? Also, other than these issues, there are some attacks or security-related stuff you might be interested in, such as DNS bailiwick rules, and you probably are interested in some attack schemes like Kaminsky attack, a cache poisoning, journey enumeration amplification attack. So there are some many good resources out there. So if you're interested in the specific topic, you can simply Google it. Yeah. So quick takeaway, quick summary is, let me go to the original figure here. So yes. So quick takeaway, when you focus on the authoritative server side, the DNSSEC deployment rate is not that good. It is because of poor support of registrar. And also from the management perspective, if you let's say, if you forgot to roll over correctly, then this single mistake can cause your entire outage of your web server. I'm sorry, DNS server. So, that is one of the reasons why administrators do not willing to support DNSSEC. So one prominent example is Slack.com outage. So Slack.com, they failed to roll over their DNS keys correctly about 2 years ago. So it causes about massive outage of Slack.com for, I guess, more than 2 hours. Please take a look. From the DNS resolver's perspective, currently, good major providers such as Google or Cloudflare, the large DNS resolvers, they support DNSSEC, but still there are many DNS local resolvers that do not support DNS correctly. So this is the kind of bleak picture of DNSSEC ecosystem. DNSSEC is really good, but still, there are lots of because of the lower, missing incentive. Still, there are many entities that do not deploy DNSSEC or do not deploy DNSSEC correctly. Okay. This is it. And the next section, we're going to talk about HTTPS protocol, which is one of the most important protocols that you use every day. But it also uses the public key infrastructure. So you might be, you should be really, you shouldn't be having a hard time to understand the protocol, right? All right, thank you so much, and see you at the next class.